In this section, we want to learn about the definition of nth root. Let's start with the square root of a. When the number b is a square root of a, that means when we square the number b, we get an a. The notation looks like this, and we read it as square root of a equals b. As I said, b is a square root of a. If b squared equals a, that means a is a number obtained by squaring a real number. So it'll be always greater than or equal to 0. That also means when a is written under the square root, that number is always greater than or equal to 0. Because of this definition, and we know that minus b squared equals b squared because minus 1 squared equals 1. So if b is a square root of a, then negative b is also a square root of a. When we consider the power form of square root of a, that is 1/2 power, because when we consider a to the 1 over power squared, that is a to the 1 over power times 2, which is a to the 1 power, which is a. So that satisfies this definition. So when we have square root of a, that means a to the 1/2 power. Of course, we always assume that a is greater than or equal to 0. When we put this notation, square root of b squared, that is absolute value of b. Meaning, when we have this notation will produce always positive or 0. b may be negative. However, when we square b, that is positive. So what's under the square root is positive number. After that, it must be a positive number. So we put absolute value sign here. The following is just a definition. Let's assume that a is strictly bigger than 0. Then square root of a is a positive square root of a. And when we put minus sign in front of square root of a, that is called a negative square root of a. If you square root to 0, that's 0. The next problem is, what is the value of square root of 16? Square root of 16 can be written as square root of 4 squared. What we know is square root is 1/2 power. So square root of 4 squared is 4 to the 1 power, which is 4. Find all real square root of 25. What we know is 5 squared equals 25, and minus 5 squared is 25. Therefore, 5 and -5 are all real square root. The above question, find all real square root of 25, is equivalent to ask what is square root of 25 and what is negative square root of 25. Simplify square root of 36 over 25. 36 is 6 times 6, which is 6 squared, and denominator is 25, which is 5 times 5, which is 5 squared. So square root of 36 over 25 is square root of 6 squared over 5 squared. So that's a square root of 6 over 5 squared. So that's 6 over 5. As we know, square root of a is always greater than or equal to 0 because we always assume that square root of the a is greater than or equal to 0. So if we multiply by -1, then it becomes negative number. And this is type of A is always positive when that's written under the square root. Evaluate the following. We have minus square root of minus 36. When we consider the definition of square root here, b is a square root of a if b squared equals a, right? So what's written under the square root sign, which is negative 36, must be real number squared. So what we can say about this is there is no number b such that b squared equals minus 36. So we cannot evaluate. But in number 2, when we evaluate negative square root of 121, negative is written outside. And what we know is 121 is 11 squared. And minus square root of 1 over 121 is minus square root of 11 squared. So that's negative 11. Always keep in mind if there's something squared, then this squared and square root sign will cancel each other. So it becomes minus 11. Where minus sign come from? That was written here. In the next problem, we have square root of minus 3 to the 4th power. When we consider this, we have to think about what the actual number is. When we multiply -3 4 times, this one is 9 and this one is 9. 9 times 9 will make 81. So that's square root of 81. That's square root of 9 squared, which is 9. So important point here is even if we wrote -3 to the fourth power, the final number is 9. Indeed, -3 to the fourth power is a positive number. The next problem is square root of -8 squared. That is square root of -8 times -8, which is square root of 64. So that can be rewritten as 8 squared. Square root of 8 squared. And I said the squared and the square root sign will cancel each other. So we have 8. The next problem is square root of x to the 12th power. A to the m power times n power is a to the m n power. So we can rewrite that as x times 6 to the second power. Then what we notice here is this squared, the squared and square root can cancel each other, and we have x to the sixth power. The next problem is square root of 81 z to the sixth power. Then the square root of 9 squared times z cubed squared by factoring 6 here. Then what we can do is reminding you a times b to the n power is a to the n power times b to the n power. We will use this principle. So we can rewrite that as square root of 9 times z cubed squared. Again, this squared and this square root will cancel each other, and then we have 9z cubed. In the next problem, we have to fill in the table. All we have to do is we will replace this x by the given number. Now, how do we interpret this function sign? The function value, the output of the function, is square root of input minus 3. Input is written here. First problem is f of 2. So instead of x input minus 3, we will write 2 there. So then that's square root of minus 1. What is problematic is minus 1 is a negative number. So that doesn't qualify to be a real number. So the function is not defined. F of 3 is 3 minus 3, which is square root of 0, which is 0. F of 39 is 39 minus 3 equals square root of 36, which is square root of 6 squared, which is 6. The next one is square root of x is 103 minus 3 equals square root of 100. That is square root of 10 squared, which is 10. So all of them are consistent to what I filled out in advance. We can extend the square root definition to nth root of a. When we say b is the nth root of a, that means when we raise to the nth power, we will get an a. And we decorate with this small n notation on the square root sign. That means nth root. So when we think about this nth root, that implies roughly a to the 1 over n power. It may be absolute value of a to the 1 over n power, or just a to the 1 over power. It depends on whether this n is even or odd. If that is an even number, then we have to put absolute value sign here before we raise to the power. Because what's under the radical sign must be a positive number, but when n is an odd number, it's okay to raise to the power this number radicand can be a negative number. Why? Because minus 1 cubed will be minus 1, which is this one is a negative number, and this one is also a negative number. But when that's an even degree power, when we raise to the even degree power, this must be always positive, right? No matter what the number, base number is, even if that is a negative number, when we raise to the even degree power, we end up with the positive number. So that's the reason when n is even, we put absolute value sign, while we don't have to put the absolute value sign when n is odd. When we consider cubed root of 8, we know that 8 is 2 cubed. In this case, we can understand the situation as 2 cubed to the 1/3 power. So that's 2 to the 1 power, which is 2. In the following problem, we want to figure out the value of cubed root of 216. The first thing we have to do will be factoring, so that whether this 216 can be written as some number to the cubed power, because in that case, this cubed and this cubed root will cancel each other, so we can remove the radical sign. 216 is 4 times 54. That can be decomposed into 2 times 27, and 27 is 3 times 9, and 9 is 3 times 3. In this factorization, 3 appears 3 times. 4 is 2 times 2, so 2 appears 3 times. So we can write 216 as 2 cubed times 3 cubed. And as we know, a times b to the n power is a to the n power times b to the n power. So we can combine these two powers and write it as 2 times 3 cubed. Then that's 6 cubed. So cubed root of 216 can be written as square root of cubed root of 6 cubed. And that can be written as 6 cubed to the 1/3 power. So those two will cancel each other, and we end up getting 6. This is cubed root of 16. This cubed, this is odd number. So we can consider minus under the radical sign. And then we can rewrite that as in cubed root of minus 1 cubed times, we already decomposed, and that turned out to be 6 cubed. Then that's cubed root of negative 6 cubed. So that's negative 6. When we compare that with this square root, that in this case, we calculate first, then we know that negative 4 times negative 4 is 16. And then the square root of 4 squared equals 4. So important point is this one is not negative 4 squared to the 1/2 power. And then you will end up getting negative number that is not. What is correct will be absolute value of negative 4 squared to the 1/2 power, and these two will cancel each other, and absolute value of negative 4 is 4. So if we put absolute value, then we get the same result. That's because that's indeed 2 is hidden here. This is an even number. But when this is odd, it's acceptable to have minus under the radical sign.